Hi geometry, hopefully this will not take long. And chords in a circle. I can describe the arcs used to design logos. Obviously that's going to be a homework problem, but here we go. Give an example of a radius, chord, and a diameter. Okay, radii. Or radius. We have B is the center. So we have BE, BG, lots of these, BD, you know, I could switch those around, but I like to put the center first, BC, BF, and BA. Those are all the radii, so pick one. How about a chord? We have, here's one right here, AC, FD, of course that's also a diameter, and CG, which is also a diameter. Remember, a chord has to have 2 points on the end on this circle. And a diameter, of course I already said those. We have FD and CG. So diameter is just a special chord. It's the longest chord. Remember that. All right, let's solve. So the first thing I'm going to do is I'm going to bring that 12 to their side and subtract 4x on both sides. So I will have 12 is equal to 4x. X equals 3. Not too bad. You remember this old stuff. Get x's on one side and numbers on the other. I'll have 6 on the left, 3x on the right. X is equal to 2. All right, here we go. Can you see that picture well? Theorem 10.3. In the same circle or in congruent circles, it could be 2 different congruent circles, 2 minor arcs are congruent if and only if, okay, that means their inverses the same, their corresponding chords are congruent. So, if arc AB, this arc right here, is congruent to CD, then the chords are the same length, okay? Or if the chords are the same length, then the arcs are. So if and only if. So let's look at example 1. Okay, we have a circle A, that's our center. Find FE and CD are congruent. Okay, so that's the arcs. So the arcs are congruent. And if the measure of arc of FE is 87, then so is CD. It's that simple. All right, I mean, think about it. This is 87 degrees. This is also 87 degrees. Those will be the same. Okay, here we go, next page. Yeah, I played over a little bit of 10.1 and it has that buzzing noise in the beginning. I don't know why it does that. All right, next one. I have 2 pictures here. One, the picture on the left is for 10.4. The picture on the right is for 10.5. So here we go. If one chord is perpendicular bisector to another chord, okay, so those are perpendicular bisectors. This doesn't have to be the diameter. Then the first chord is the diameter. I guess it does have to be a diameter. Okay. QS is perpendicular bisector of TR. Then QS is the diameter. Okay, so basically you have 2 chords that are perpendicular bisectors. Then you know that's the diameter. Okay, so basically I can put a dot there for the circle or the center. And then if the diameter of the circle is perpendicular to a chord, then it bisects. So then we know this. Okay, so that will come after. So basically those are inverses of each other. Ooh, this one's a good one. 3 points are placed on a stage at points PQR as shown. Describe how to find the location of a table so it is in the same distance from each prop. Does this sound familiar? Okay, let's see here. I tried to draw this. Basically, if I have that, and I draw a perpendicular bisector right there, and I have this to be the same length with a perpendicular bisector This should start looking like something. Kind of familiar? I know it's roughly drawn. It's like a sketch, but basically you draw two perpendicular bisectors and it gives you the circumcenter. So that should look familiar, and we have that on the wall in a classroom. You can check it out again. Example 3. Use a diagram of circle D to find the length of YZ or ZY. Tell what theorem you used. Well, if this is a chord, it's perpendicular, these will cut in half, so that has to equal 10. And what theorem did I use? 10.5. Okay. Simple, simple. Alright, so it's been 7 minutes so far. Hoping to get this done. Do a little soccer. Alright. Wonder if you heard Blaze. He was in here earlier and I was like telling him to shush. 10.6. In the same circle or congruent circles, two chords are congruent if and only if they are equidistant. Okay, so not only will the arcs be congruent, but then also this distance is the same as this. Okay, so it's another if and only if, so you can also switch that around. If the lengths are, if these are equidistant, then you know the chords are congruent. Alright, so here we go. Example 4. In circle M, you have MG is the same measure as ME, and AB is equal to 2x plus 6, and CD is 3x minus 1. Find AB. Well, if these two are equidistant, that means those are the same, so set them equal to each other. 2x plus 6 is equal to 3x minus 1. And this is why that was in our warm-up. Subtract 2x on both sides. 6 is equal to 1x minus 1. Add 1 to both sides. X equals 7. I know, it sounds simple. I do recommend making... actually, I have some cheat sheets for these circle theorems. I will find them really soon and get them to you. There's our homework and our Common Core Standard, but look! I have extra. I feel this should have been added somewhere. I don't think it was in the notes, but I think it's actually important. So here's a circle with the center. Okay, take a look at this. Okay, obviously these are two radii, right? And look at this. This angle is going to be the same as that. That arc length is going to be the same as that. So notice the arcs when the chords are parallel, okay? These chords are parallel. This arc length is going to be the same. Actually, really important. So BC is parallel. Oh, I can't see the letters. This is B, and this is C. Is parallel to AB. Here's A. That's supposed to be AD, sorry. And here's D. So if those are parallel, then arc AB is congruent to arc CD. Okay, so I think this should have been somewhere in our book. Maybe they just don't cover it. But in any case, have a happy Saturday, and I'm really psyched. I just cranked out 3 videos, and I'll probably do one more tonight, and just a couple more, and I'll have chapter 10 done. Take care.